Hello, and welcome to the Big Bang. Having an intuitive understanding of how a body moves through space will be very important in all classes you take in mechanics and biomechanics. One good way to develop this intuition is by breaking down the most basic of steps. Let's start with a general 2D plane motion for a rigid body. Picture this random rigid body in orange. Let's highlight 2 points in this body and try to understand how they moved around as a rigid body moved across a plane. This second drawing of the body is the body after it moved across the plane. Think of the plane in this case as the screen, so the body just moved further right on the screen. The 2 points and the line represented between them are now drawn in pink. Notice if the body had simply translated across the screen, the line would be represented by this dashed blue line. Now, the fact that one of the points does not match means that the body rotated in addition to having translated across the screen. So it seems like the body translated and rotated to arrive at its final form. Let's begin to think of this mathematically. The first blob will represent the translation, the second will represent the rotation, while the third will represent the full plane motion, that is a rotation plus a translation. In a rigid body, every point has the same linear acceleration. So if the body had just translated, which is actually what point A did, we would get an acceleration that has both tangential and normal components associated with the motion, where the velocity is the same between all points. Now with the rotation, we saw that only point B moved around. We can assume that B rotated about the reference point A, which did not move. We can then draw angular velocity and linear velocity v of B relative to A. Adding the two events, the body both translated and rotated. While the velocity at A is only due to the translation, at B we have components associated with the translation and the rotation. Thus, the acceleration at B will be A of A plus A of B given A. Let's sketch another body with 2 points, A and B, on a reference frame XYZ. The distance between the 2 points is given by the vector r of b given a, where r of b given a equals r of b minus r of a. To find the position, velocity, or acceleration of one body relative to another body, all you have to do is take the difference between the two vectors. So if we are trying to find the velocity of point B, we need to add the velocity of point A to the velocity of B relative to A. But notice that this velocity of B relative to A will only exist if the body is rotating. Otherwise, VA equals VB. We can find V of B given A by using the definition of the velocity, the angular velocity crossed with the position vector of B relative to A. Similar train of thought goes with finding the acceleration at point B. We add the acceleration at A to the acceleration of B relative to A, where the acceleration of B relative to A is given by the angular acceleration crossed with the position vector of B given A plus the angular velocity cross the angular velocity cross the position of vector of B given A. Okay, this is all for now, and I will see you next time.